Hello everyone and welcome to the videos for the cumulative review packet number 9. Let's get started with some polynomial vocabulary. So number 1 is asking first if this polynomial is in standard form. It is not, because the term with the highest degree has to go first. So this subtraction sign is really a negative. You could think of it like that. So this first one in standard form would be negative 8x to the third plus 5x, because the 5 is positive. Now that it's in standard form, I can see that the biggest, or the highest degree is 3, and a polynomial with degree 3 is called a cubic polynomial. And the name based on number of terms, because this polynomial has 2 terms separated by a plus or minus sign, it has 2 terms, which means that this must be a binomial. So this polynomial is called a cubic binomial. Number 2, is this in standard form? Well, no, the highest degree has to go first. So we're not looking at the coefficients in front. We are looking at the highest exponent down to the lowest. So this in standard form would be negative 3x to the fourth plus x to the third minus 10x squared minus 4x. Because we went from the degree of 4 to 3 to 2 to 1 technically. The highest degree that I see in this example is a 4, and a polynomial with degree 4 is called a quartic polynomial. 4 and core rhyme, that's how I remember it. The number of terms that I see 1, 2, 3, 4 terms separated by plus or minus signs. So because there is 4 terms, anything with 4 or more terms is just called a basic polynomial. So the number 2 is called a quartic polynomial. Number 3, this is only 1 term, so it's already in standard form. So we're done with that first part. The highest degree that I see, well, on a variable, when I don't see a degree, I assume it's 1. So this has a highest degree of 1, which means that this is a linear type of polynomial. And because I only have 1 term, this would be a monomial, because there's no plus or minuses in there. So this polynomial is called a linear monomial. Last but not least, number 4, this again is not in standard form. The highest degree must go first. So negative 2x to the fifth minus 3x, then the 9 is positive, so plus 9. The name based on degree, the highest degree that I see is 5, and the name for that is a quintic polynomial. The number of terms that I see would be 3. I see 1, 2, 3 separated by a plus or minus sign, and that would be called a trinomial. So if any of this vocabulary you need to review, remember we did take notes on this section, as well as there was another flipped video re-explaining this vocabulary, so I hope you have that as a resource as well. Numbers 5 to 10 here are just the directions, or just to simplify the polynomial, and it's up to you to determine, am I adding, am I subtracting, am I multiplying, what is the problem asking me to do. So if I look at number 5, it looks like what I'm doing is adding a polynomial plus a trinomial. And when I'm adding, I need to look for like terms. So in a way, these parentheses don't really matter, except that it's telling you that you're adding a polynomial plus a trinomial. And so what I'm going to do is just scan and look for my like terms, highest degree to lowest, so it's in standard form. Here's like terms. 6a to the fourth minus 8a to the fourth is negative 2a to the fourth, so that's how many a to the fourths I have left. I notice I have a negative 5a to the third and a negative 4a to the third, which would be negative 9a to the third power. I then have a negative 5a squared, but I do not have anything else to combine that with, so I would just write that next. And last but not least, I have an 8a and a 2a, which can combine to be 10a. So this is my final answer here, because I cannot combine any other terms because they are not like. They do not have the same exponent on the base of a. Number 6, what it's really asking me to do is, here we are asking really add or combine. Here we are really subtracting the polynomials. So I'm really taking a binomial and I'm subtracting a trinomial. Now, the only difference between 5 and 6, in my opinion, is that this negative affects everything in the parenthesis behind it. So I am going to just keep the first parenthesis the same. I'm going to keep negative y squared minus 3y to the third. And then I'm going to change the sign of everything in this parenthesis. So we have a plus 7y to the third, a minus 5y, and a minus 6y squared. But after that point, we are really just combining like terms again. So the highest power that I see is to the third. So negative 3y to the third plus 7y to the third is 4y to the third. I have negative 5y squared and negative 6y squared, so that's negative 11y squared. And then I just have negative 5y that would go at the end of the problem if it's put in standard form properly. Number 7 and 8, however, are not asking you to add and subtract. They're asking you to multiply or distribute this monomial times the trinomial. In order to do a monomial times a trinomial, we need to distribute that into each one. And when we distribute that in, remember that we multiply the numbers and add the exponents. So if I were to do that over and over again, these first two multiplied would be negative 20 r to the fifth power, multiply the numbers, add the exponents. If I looked at the second one, negative 5r to the cubed times negative 2r is a positive 10r to the fourth, because this is really r to the first power. And then negative 5r cubed times negative 5 is a positive 25r cubed. My answer is done here, because just like the previous examples, I do not have any like terms. So as I said in class a couple times also, I can multiply anything I'd like. Remember that you can change exponents when you're multiplying or dividing. But when you're adding and subtracting, you never ever change the exponents. For instance, when I combined these two a to the fourths together, I did not change the exponent. You only change it when you're multiplying. Speaking of that, if I distributed in this monomial to this trinomial, my first term, so negative 2 times negative 6 is 12. S squared times s to the third is s to the fifth. T to the fourth times t to the fifth is t to the ninth. So that would be my first term. My second term, negative 2 times 6 is negative 12. S squared times s to the first is s to the third. T to the fourth times t to the fourth is t to the eighth. And then my last multiplication here would be negative 2 times negative 4, positive 8. S squared just comes along for the ride, nothing to combine with. T to the fourth times t is t to the fifth power. Now in this example, don't worry about standard form as much. There is a rule I haven't taught you yet, just to throw it out there, that if you have bases that are different, you would just look at the sum of the exponents to see if it's standard form. And because this is 14, 11, and 7, it is in standard form. Don't worry about that for your test. That'll come up as we keep going through the course. Numbers 9 and 10 are, again, using the distributive property. What we're doing is multiplying a binomial times another binomial. But to do that properly, we have to multiply the 2x times both terms in this, and then the 8 times both terms in this parentheses. So if I were to look at the 2x first and distribute that in, 2x times x is 2x squared. 2x times negative 5 is negative 10x. Then I've distributed the 2x, so I move to the 8 and I distribute both of those. 8 times x is positive 8x. 8 times negative 5 is negative 40. I then scan to see if I have any like terms, and I do, here in the middle. So my final answer would be a trinomial, 2x squared minus 2x minus 40. Number 10 is when we're multiplying a binomial times a trinomial, and it's going to be similar in idea to number 9. I am first going to distribute the 6y in to all three terms in the second parenthesis. And if I do so, I would have a negative 42y to the third, because I'm still multiplying the numbers and adding the exponents. 6y times 2y would be a positive 12y squared. 6y times negative 3 is a negative 18y. Now if I switch to distributing the negative 4 to all three terms, I'm going to line them up with like terms underneath. So negative 4 times negative 7y squared is a positive 28y squared. Negative 4 times positive 2y is a negative 8y, and a negative 4 times negative 3 is a positive 12. If you like this method, it just helps line things up a little bit more so you can see what can combine. So my final answer would be negative 42y to the third. These two terms are like because they both have y squared, so that would be plus 40y squared. These two are like terms, and that would be minus 26y, and then plus 12. So this would be my final answer as a polynomial for number 10 in standard form. Number 11 and 12 are also the same idea. These are the quote-unquote special cases, however. What I mean by that is if you look at number 11, this does not mean 6g squared and then negative 4 squared. Remember that if we are doing a binomial squared, what this really means is the what's in the parentheses times itself. So it's really 6g minus 4 times another 6g minus 4. And this problem now, in my opinion, ends up looking a lot like number 9, that we have to distribute both pieces in. So if I look at number 11 now, and I distribute the 6g to both terms in the second parenthesis, that would be 36g to the second minus 24g. And then if I distribute the negative 4, I would have another negative 24g, and I would have a positive 16. Both of my middle terms are the same, but they do not cross out because 2 negatives is still a negative number. So my final answer would be 36g squared minus 48g's plus 16. So no, the middle term does not cross out in this example. And please note again that g plus g is never g squared because you're combining like terms and not multiplying. Number 12 is also the same type of idea, except this is another special case because when I distribute the 3x in first, that would be 9x squared. 3x times negative 9y is negative 27xy. And then if I distribute the 9y to both, 9y times 3x is also a 27yx, but that's the same as xy because when I'm multiplying. And then positive 9y times negative 9y is negative 81y squared. So the reason this is a special case is because my two middle terms technically combine to be this, 9x squared plus 0xy minus 81y squared. But a lot of you know that 0 times x times y is really just 0. So this, in a way, crosses out. So my answer would just be 9x squared minus 81y squared. Number 13, what we're doing is, again, multiplying, because there's nothing in the middle of these parentheses. So we're multiplying a trinomial times another trinomial. And this one is definitely has a lot to it. We have to do a lot of distribution. The first thing we would do is distribute the x squared to all three terms. X squared times x squared is x to the fourth. X squared times 6x is a positive 6x to the third. X squared times negative 5 is negative 5x squared. If I now distribute in the negative 2x to everything, negative 2x times positive x squared is a negative 2x cubed. Negative 2x times positive 6x is a negative 12x squared. Negative 2x times negative 5 is a positive 10x. Lastly, if I distribute the 4 in, I would have a positive 4x squared, I would have a positive 24x, and I would have a negative 20. Notice again how I line things up. So now I notice that I have these as like terms, I have these as like terms, and those. So my final answer would be x to the fourth plus 4x to the third. Let's see, negative 5, negative 12 is negative 17, plus 4 is negative 13x squared, plus 34x minus 20. So this polynomial is my final answer because there are no like terms left. So I will continue with number 14 on the next video. Thanks!